These notes are on quadratic regression, and quadratic regression is done using your calculator. And so given a series of data points, we're able to create the equation. So this is used in real life quite a bit because you don't necessarily know the equation, but you know the shape is a parabola, you know the points, and so then you can use your calculator for it to generate the formula for you. So on the first one, we want to figure out what the equation is. And so to do that, we're going to use our calculator. All right, so when we open up our calculator, we're going to go to a menu we haven't used before. And that menu is going to be the stat menu. Okay, and the first thing we want to do is enter the information into the calculator. So we want to edit, so we're going to hit 1. Okay, in list 1 is going to be all the x's from our ordered pairs. So in list 1 is going to be -2, 1, and 3. So we're going to have -2, you're going to hit enter. Now notice it's going to round to 2 decimal places for you. That's because we set the float to 2 decimals last time, and that's okay. It's not going to change the answers, and it's going to help us later on. Okay, so then we need to go to list 2. In list 2, we're going to enter all the y values. So in there we'd have 32, and then 5, and then 17. All right, now that we have all the values in, now we need to tell the calculator to calculate it. So we're going to hit stat, and now we need to go to calculation. So we go to calculation, and we want quadratic regression, which is option 5. So you can scroll down or just hit the 5. Okay, so then this tells us that's going to take the x values from list 1, which is where we put them, the y values from list 2, which is what we did, the frequency list you don't need to do anything with. But the next one, store regular equation, that we do want it to do because we want to be able to look at this graph later on. So I am going to go to hit this variable button that says bars, B-A-R-S. And I'm going to go to y variables, and I want a function, so I'm going to press enter, and I want y1. That's where I want the graph to be. And then I'm going to hit calculate, and it'll give me my answers. So A is 3, B is -6, and C is 8. Oh, can't write in highlighter. A is 3, B is -6, and C is 8. Okay, once we have our values, then we can write our equation, and the equation goes in the standard form. So all of these are going to be y equals ax squared plus bx plus c. So my a is the number in front of the x squared, so it's going to be y equals 3x squared minus 6x plus 8. There's my equation. Okay, then I need to see if the vertex is a minimum or a maximum. Well, since it's a positive A, I know it's going to be opening up, which makes it a minimum. And now I need to calculate the minimum value. And the minimum value is the y value of the vertex. Okay, and we talked about that before. But now we need to calculate it. So I'm going to go back to my calculator. And if I hit y equals, that graph is already there. Now, I don't know exactly where that's going to be, so let's try a standard graph. Zoom 6, see if we can see it. And there it is, and there is our minimum right here that we can see, so we need to calculate it. So second, calculate, the minimum is 3. So I hit on the left, go around the right, and then my guess. So my point is 1, 5. Okay, 5 right here, the y value is the minimum. You do not record the x, only the 5. So the y value is 5. All right, let's try this again for the second one. So we're going to go back to our calculator, go to the stat menu. We want to edit the information in. Well, now I've got information in there that I need to get out of my calculator. So I'm going to go up to put my cursor where it says L1, and I'm going to hit clear, and then I'm going to hit the down arrow, and it'll go away. Go back to L2, clear, down arrow, and it'll go away. So now remember, in L1, I'm going to put all of the x values. So in list 1, I'm going to put 2, -1, and -4. And then for my y values, that's going to go in list 2. So all of these will go in list 2. So my y values would be -12, -15, and -90. Now that I have the numbers in, I'm going to hit Stat. I need it to calculate, and we're doing quadratic regression, which is 5. If you forget, quadratic regression is listed in the top of your paper. List 1 is our x's, list 2 is our y's. Frequency list we'll leave blank, but now we want it to store that equation. So to do that, I'm going to hit the variable button. I'm going to write over to the y variables, and I want it to be a function. I want it to be y1. I'm going to scroll down and hit calculate. So now I know that a is -4, b is 5, and c is -6. So for this equation, a is -4, b is 5, and c is -6. So my equation is y equals -4x squared plus 5x minus 6. Now this one is opening down, so because of it's opening down, right, the vertex has to be up here, so it's a maximum. Well, let's figure out that maximum value, which remember is going to be the y value of the vertex. Okay, so my graph is already in there. Let's just start a standard window, and then if we need to adjust, we can. Nope, it's there. We don't need to adjust at all. Okay, so I'm going to hit second, calculate, and my maximum is option 4. Well, it's right where I need it to be for the left bound. Scroll over, get the right bound, hit enter, and it's very possible we're going to get a decimal on these. Now, I don't care what the x is, I just want the y, and because we already set the float, it's already rounded for us. So it's going to be -4.44. All right, now we're going to do this again, but this time it's just got more values for us. So this L1, this is x's, this is going to go in L1, and this is going to go in L2. So I go back to my calculator, I go to the Stat menu, I need to edit. I put my cursor up on L1, I hit clear and down arrow, it clears the list. I go back over here, clear and down arrow, it clears the list. And now I'm going to plug them in. Now make sure you get them in order. So I have 0, enter, 0.5, 1, 1.5, and 2. Arrow over, put in list 2. 35. Now make sure the 35 matches with the zeros. They've got to line up correctly, otherwise your points are messed up. 36, 29, 14, -9. Now I've got my information in. I'm going to hit Stat. I need to calculate it. I need to do quadratic regression. And those things stay the same. To put in the equation, variables, y variables, function, y1, go down to calculate. And on this one, we get a is -16, b is 10, and c is 35. So when I write my equation, okay, my equation is going to be y equals -16x squared plus 10x plus 35. Well, now I need to graph it to find this maximum value. And I know it's a maximum because it's going down, right? Because it starts with a negative. Now, when I am setting up my window, having the table really helps. Notice my values go from 0 to 2 for x, so maybe we'll do like 0 to 5. And then my y's, the lowest is -9, so maybe we go from like -10 to 40 because that covers everything. Let's see what happens. So on the x's, we're going from 0, it went to 2, but I'm going to go to 5. And on my y's, the lowest one is -9, so I'm going to go to -10. and I'm going to go up to 40, and I'm going to maybe count by 5 this time. And look, I can see my graph. Okay, so now I'm going to calculate the maximum. So calculate, maximum is 4. Now notice my y is at negative 40, so I need to hit the left arrow, not the up key. Get all the way over here on the left, and then all the way over here on the right. Enter, enter again, and I get 0.31 for the x, but we don't care. For the y, I get 36.56. Now for these problems, we've just been doing it for just random problems, but we can do these for word problems too. So let's put these into our calculator. This is the points that they took. Amelia was measured 3 times when doing the long jump. So her midsection, so like kind of to her belly button, how far is the belly button off the ground as she's going through her mid jump? Okay, so she'd go up, or her long jump. So she'd go up and then she'd go down. So let's put those values in. So we're going to go to stat. We're going to go to calculate. Just kidding, we got to go to edit first. Edit. We got to clear out the list. So go to L1, clear down arrow. Go over to L2, clear and down arrow. And then in L1, we're going to put in the numbers 0, 0.5, and 1. Over here for L2, we're going to put in 0.7, and 1.5, and 0.55. And enter. Okay, go to stats. We want to calculate quadratic regression. These two stay the same. And now we're going to do our equation. Variables, y variables, function, y1, go down to calculate, and away we go. So on this one, A is negative 3.5, B is 3.35, and C is 0.7. So when I go to write my equation is going to be y equals negative 3.5x squared plus 3.35x plus 0.7. Okay, now use this to figure out your window when you graph it. This goes from 0 to 1, so maybe like you go to 0 to 2. And these numbers are all real small. Maybe we just go 0 to 5. Maybe on all of them we just go 0 to 5. So our window, let's do that. Let's do them both 0 to 5. See what happens. And remember, we don't have to put our graph in because we already tried the calculator to do so. And then we hit graph. Oh, there it is. Now, if you don't believe me, hold on, it's still working. In the y equals, look, there's that equation we just wrote. Okay, and there's the graph. Calculate the maximum. Second, calculate. Maximum is 4. Look, this is at negative 12, so I'm going to use my left arrow to bring it back up. It's getting there. Closer, closer, closer. Yeah, there it is. Okay, so here's my left boundary. Here's my right boundary. And there's my guess. So 1.5 is the maximum, because remember we just recorded the y value. So we're going to do 1.5. Now this is a word problem. We're talking about the height, because that's the y. So it's meters. So at her max, she jumped. At the max, she was 1.5 meters off the ground. Okay. Now the last one is a word problem, but another one, and I'm not going to do this one again, but this is your ordered pair. So this is your x, your y, your x, your y for all of these. So you're going to put them into your calculator just like we've been doing. Write the equation, find the maximum height.